Sorry about that intro. Hi guys, I miss you already. We will be doing a video today. I told the sub to play this through twice. So if you miss something, you can ask a friend or you can wait until the sub plays it again. Okay? All right. So first, I want you to go to Canvas. Let's turn this off so that, or not. We don't have to turn that off. Okay. So go to Canvas, go to modules like we always do. And today is 9/19, so let's click on that. All right, a lot of stuff. It looks like a lot going on, but it's really not. These are the instructions that the sub has today. So it says, hi, you have a sub today. The sub will have these instructions. They may not work in the hallway or use their phones. Please take any phone you see that's out. Students may go to the restroom one at a time. First block, please have Hannah and a friend or Tanner and a friend, whichever group wants to go. Take the calculators to room 412 at 9:48. Please give Hannah 2 to 3 extras of the notes to put in the daily folders. They will watch the video and fill out the notes. Please play it twice. They are to work on their homework after the notes. All right, the homework key is on the board, or should be if I remembered after this video to go do it. Okay, so here are your notes in case you're absent. Here's calculator help to, okay, well, that's lovely. Well, it won't let me move. All right. So here's calculator help in case you want to, if you need help putting in the information into the calculator. Okay. And then here's the annotated notes in case you get lost. Okay, so this is what we're about to work on. And you have it right there on Canvas. Okay. All right, let's. All right, sorry guys, I don't know what's happening. All right. The rest of the information, this is what, these are your instructions. Please follow along with the video. The sub will play the video twice in case you miss something. I will also post the video here. I'll put a link right there in case you're absent or forgot everything in class. You need the notes and a calculator. Put up your Chromebook after you read Canvas. Don't forget you have a vocabulary quiz on Monday. If you lost your sheet, check the Wednesday folder. If there are no copies left in the folder, use this link to copy down the words on your own sheet of paper. Here are the definitions. Read the instructions at the top of your vocab sheet to find the definitions easily. Vocab is due 9/22. Okay, here are the answers. Here are the problems for homework. This sub will give you the paper version of this. Answers will be in the binder or on the board if you're in first block. Be nice, don't do drugs, wear a seatbelt, have a good weekend. All right, so let's get started on the notes. So right now you need to put away your Chromebooks or your CBs. You need to grab a calculator. And you need to only have out these notes, a pencil, and a smile. All right. So yesterday we talked about simple interest. So now we're going to look at compound interest. So compound interest. Compound interest is computed on the original principal as well as on any accumulated interest. Accumulated just means like gather or built up. Okay, many savings accounts pay compound interest. So that's really important. Let's underline that. Many savings accounts pay compound interest. For example, suppose you deposit $1,000 in an account at a rate of 5%. This table that's below shows how the investment grows if the interest is earned automatically added on top of the principal. Okay. So this is the chart. It looks more complicated than what we're actually going to do. So we're going to use a nice formula and we won't have to do every step every year. Okay. So what we're going to do today is we're going to use the compound interest formulas and we're going to calculate the present value. We will not do that last one today, so you can cross that off. Okay, so if we look at our example from yesterday, all right, which was the simple interest, where we only added the 10% of the principal, okay? When we are looking at compound interest, okay, I find 10% of 1,000, which is 100, okay, and we add it. So that is just like the first addition in the simple interest, okay? Now, things start to change. Things start to change when Things start to change after that first year. Okay, so instead of taking the 10% of the original, now we're going to take the 10% of our previous balance. So instead, we find 10% of 1,100, which would be 110. So already, after the first year, we are getting more money than just the simple interest. So now I add that interest here. Okay? So if we look at the end of year 2 for both compound and simple, if we look at those years, I'm already $10 ahead. Okay, I know that's not much to you, but if we're thinking of a big account like $100,000, that can actually add up pretty quickly. Okay, so now I take 10% again, which is what we did here. But remember, for simple interest, we went all the way back to that original number. But for this interest, compound interest, I'm just going to the previous balance, which is more money. So that ends up being $121. And when I add it, I get $1,331. Okay? So by year 3, this has $31 more. Like I said, with this small amount, it doesn't seem like it's a big deal, but remember, you could have, if you wait like 30 years or 15 years, this could really make a difference, okay? So if we're looking at simple interest, which is on the left side here, it ends up looking more like a line. So it ends up being more linear. Okay? If we look at the compound interest, it's growing at a faster rate, which is great if we're investing money. So this would be exponential. Okay? So we really don't have that many different letters to worry about. So go ahead and turn your page. Okay? We still have the same letters. There's only one new letter, okay? And that we'll talk about in just a second. So FV is our future value, or account balance. Okay, P is principal, just like yesterday. Principal is our initial or beginning amount. We have rate is R, just like yesterday. So remember, that's a percentage to a decimal. Then we have N, which is number of times in a year. And that is really important because that can help us with our money growing faster and faster and faster, which is nice, okay? Then T, just like always, is time in years. All right, so nothing has really changed except for this N, okay? So it's not that crazy, okay? But if we look, here is N. It is right there. So let's see how that works out in our problem. Okay, so you deposit $2,000 in an account at Hometown Bank, which has a rate of 1.6%. Find the amount A, which is also FV, right? A is the same as FV, okay? So we're going to find the money in the account after 3 years, subject to interest compounded once a year. Okay, so you see how that N, we talked about number of times in a year. Right here, that's what it's going to actually tell us. We don't have to be a mind reader or anything to figure this out. It'll tell us what we need, okay? So once a year, that means N will equal 1. Crazy, I know. So we're going to find the amount of money and then the interest. Okay, so let's put it all in there. So future value or A, it doesn't matter. We're going to put our principal in. 1 plus, okay, my rate is 1.6. I've got to change that to a decimal. So that is 0.016 divided by N, right here. That's where I am in the problem. N is 1.
Hey,
Raised to the...
Get it? All right, my bad.
That's Mr. Harris. I'm not starting over. I'm in the middle. Raised to the 1 times 3. That was Mr. Harris, everybody. Okay, now this first one, it's not that crazy because n is 1, and 1 times anything or anything divided by 1 is the same number. So I'm just going to take that out because we can. So 2,000, 1 plus 0.016 raised to the 3rd power. All right, so let's put that in the calculator. So I've got 2,000, 1 plus 0.016 raised to the 3rd power. So I get $2,097.54. Okay, now that is how much we would have at the end of 3 years if it was being compounded once a year. So what does that mean, being compounded once a year? What that means is that you're adding interest that many times a year. Oh my God.
For the interruption, students, if you are staying to work for service hours, you will meet Ms. Graham in the pit. Thank you.
Okay, so if you want to find the interest, all we have to do is take our total amount and subtract that principal. So I'm going to do $2,097.54 minus what we put in there, right? 2,000. So over 3 years, we made $97.54. Okay, so because we were interrupted several times during that one, let's try that again. So you deposit $1,000 in an account that has a rate of 1.4%, okay, and the interest is compounded once a year. All right, so let's find that. So the future value is equal to the principal plus 1, okay? And then I have, if I'm using this formula right here, then I've got plus 0.014 over n, and we said n was once a year, so that makes it 1, raised to the n, which is 1, times t, and t is 5 years. Okay, so let's put that in our calculator. And once again, I don't have to divide by 1 or multiply by 1 because it'll be the same thing. So 1,000, 1 plus 0.014 raised to the 5th power. So I get $1,071.99. Okay, and if I want to find the interest, I would just subtract. So 1,071.99 minus 1,000. And that would get me the interest. Okay, so let's figure out what happens when it's compound interest more than once a year, okay? And honestly, when you're looking for a savings account, you're going to want more than one time a year, I promise. Because the more time you compound, what that means is that it's grabbing your account, multiplying the interest rate, and then adding that amount to your account. So the more times it does that, the more money you get. So, the period of time between two interest payments is called compounding period. Okay? All right. When the compound interest is paid once per year, that means it's compounded annually. Okay? Most savings accounts will have plans in which the interest is paid more than once a year. And once I said, that's what we want. Okay. If we say that the interest is compounded semi-annually, we're talking twice a year, okay? If it is 4 times a year, then it's compounded quarterly. Think about quarters, right? There's 4 quarters in a dollar. So if it's compounded quarterly, that is 4 times, okay? So let's look at these real quick. So these are popular ones. So we have semi-annual, N equals 2, because it's 2 times per that year. Quarterly, N equals 4, because 4 quarters in a dollar. Okay, 4 quarts in a gallon. Monthly, N equals 12, because there are 12 months in a year. So what about daily? How many days are in the year? 365. I haven't really seen this one, but you know, it's just fun. Weekly, N would equal 52 because there's 52 weeks in a year. Make sure you write that down. Okay, so let's look at computing all of those. So what we're using is that formula FV equals P times 1 plus R over N raised to the R times T. And yes, don't worry, you will be able to have these formulas on the next quiz, okay? Okay. So we're going to show what a difference it actually makes. So calculate the future value of a $6,000 deposit into a savings account paying 5% interest for 10 years. Okay, so we're going to do this problem 3 times. Okay, and why is it 3 times? Well, we're going to show the difference in the amount of money you make if it's compounded daily, monthly, and quarterly. So let's look at that first one, daily. So if it's daily, N equals 365. P is 6,000, right? We have that right here. R is 5%, so that's 0.05. And T is 10 years. All right, so we're going to plug that in to our equation. So it is, remember, I'm using this equation here. So 6,000. Okay, and I'm sorry, these are so tiny. All right, so it's the rate, so that's 0.05. Honestly, let's do this so that you can see a little better. There we go. Okay. So 0.05 over 365 raised to the 365 times 10. Okay, so now you're probably looking at this like, how the heck am I going to put this in the calculator? Let's go ahead. It's not that crazy. So 6,000 parentheses 1 plus, all you have to do is do 0.05 divided by 365. That's all you have to do. Okay? You have to close the parentheses though. Okay? Now you're going to hit the caret button and you're like, what? Look at the button below clear. That little tiny like bloop arrow, you're going to click that and it brings you to the exponent world, okay? And that's where we're going to do 365 times 10. All right, so I've got 9,891 and 99 cents. All right, let's put that down there. So future value or account balance, however you want to look at it, is $9,891.99. Woo! Okay, next, let's look at monthly. So nothing is going to change. P, R, and T. The only thing that will change, the only thing that will change is N, because now we've gone from daily to monthly. So N changes to 12. Okay, so 6,000, 1 plus, let's do this little guy again so we can see better. Okay. 0.05 divided by 12, and then 12 times 10 up here. Okay, let's put this bad boy in a calculator. So 6,000, 1 plus 0.05 divided by 12, raised to 12 times 10. 9,882.06. So far, which one is winning? Right? You're going to make more money daily because it's compounding and adding to your account over and over and over and over again. Okay? So let's do the last one, quarterly. So the only thing that'll change is that N equals 4 now. So 6,000. Okay, our rate is still 5%. Okay, time is still 10 years. So that's going to be 0.05 divided by 4 raised to the 4 times 10. Okay, let's put this bad boy in the calculator. 6,000. Parentheses. 1 plus 0.05 divided by 4. Close the parentheses, very important. Caret 4 times 10. $9,861.72. Okay, so the winner is if it's compounded daily, right? Get that money, more money, not more problems, okay? Okay. Let's do that again. We'll do only one of them. So let's choose. Haha, y'all don't get to choose. Let's go with quarterly. Quarterly. Okay, so that means that our N equals 4. So our principal is 10,000. Our rate, it says 4.8, so that's 0.048. Time is 9 years. So let's plug them in. Okay, so we've got 10,000. All right. Our rate, 0.048. Do not round that. I know y'all love rounding, but do not round that. Divided by 4 because it's quarterly, and raised to the 4 times 9. Let's put it in the calculator. All right. 10,000 times 1 plus 0.048 divided by 4. Close the parentheses. Raised to 4 times 9. Booyah. So $15,363.79. Okay. So the more money you invest, the more money you'll earn. Okay? Because 4% of $100,000 is going to be more than 4% of $100, right? You're going to earn a lot more money the more money you turn in. Okay, now we've got something different. And you're like, oh my God, on our Friday. Okay, but I promise it's not that bad. It's actually easier. So if it says continuously, you have less work to do, actually. It's nice. So continuously is kind of hard to wrap your head around, okay? It's more than daily. It just keeps on going, okay? You're obviously going to get more money this way, but not much more than you actually think. Okay, so instead we use good old Pert. It used to be a shampoo. I don't know if it was when I was alive. I'm not sure. Anyway, so E is a cool little button that we will look for in a second. E is a great number where it's like 2.17. Give me a second. Yeah, 2.718. Okay, it's not like some fictional character. E is equal to 2.718. It goes on forever. Like pi, it is irrational, meaning it doesn't stop. It doesn't have a pattern. It doesn't repeat. Okay? So we're still using principal. We're still using rate. We're still using time. Okay? We just got a little E in there. Not a big deal. Okay. Calculate the future value of a $5,000 certificate of deposit. That's a savings account. Sounds crazy, but it's not. Paying 6.5% interest compounded continuously for 5 years. So when you see that continuously, that means you use E. So FV equals 5,000 times E raised to the 0.065. Let me move that out of the way. Times the time. Oop, and we know the time. My B. 5. Okay, we're just gonna plug that baby into the calculator. All right, so 5,000. So to get E, I need you to hit second ln. Second ln. Okay, raised to the, then you're just gonna type 0.065 times 5. When you type the E, it automatically puts you up into the exponent, okay? So I get $6,920.15. No. I'm recording right now. And Nick's not here. Okay. All right. Last one. So we've got 3,500 times E raised to the 0.0825 times the time, which is 16. Okay, let's put that in our calculator. 3,500 second ln 0.065 times 5. Oh, nope, times 16. Sorry about that. People trying to walk in here and that was 16, my bad. Oh my, I just messed up the whole dang thing. Let's just start that over. Okay, 3,500 second ln 0.0825 times 16. Woo, we were about to do a whole different problem. So $13,101.97. Okay. Sorry for all those interruptions, guys. Yeah. Well, so I'll let you know who came in. We had Mr. Harris was number 1. Nope, he was number 2. Miss Turner was number 1. Mr. Harris was number 2. And Ernie Roberts was number 3. So, sorry about all those interruptions. The notes for today are in Canvas. I already showed you that. Here are the last couple times I went through this. Anyway, so you need to work on your homework. And thank you for listening. The sub will play this again, and I'm sorry if it's annoying. Be nice. Don't do drugs. Wear a seatbelt.